Hello. Just to check. Okay. Can we start? Hi. So, okay, I started recording both. Okay. So, welcome for the lecture 3. So, as according to the plan, we are going now a step further from the previous lecture so that we start with FCification and portability challenges for creating serverless workflows, or how we call function choreographies. Objectives of this lecture are four in general. First, I will present briefly what are the workflow applications and how to build them explicitly or implicitly. Then we will focus on serverless workflows and function choreographies and how to build them. There are two ways: from scratch or from the existing code. Part of that we covered last week, but now together with control and data flow. Then portability challenges. Since we have multiple workflow management systems, especially focused even with serverless, there is a challenge how to migrate from one cloud provider to another, or from one FC system to another FC system, which steps are needed, and how we approach to this problem. And we reached to our language AFCL, which will be used later in the course, also in the next week and the week after, so that some basic constructs I will cover today and next week, and next topic, and the topic afterwards, I will cover additional features of the language, and of course of the engine that supports the language. Of course, the engine does not support yet all constructs, but supports all constructs that you would use in the course. Okay, so let's start now. We have an applications that we would like to execute in the Edge Cloud Continuum. And usually applications consist of multiple activities that should be coordinated, and the application coordinates individual, let's say, tasks of inside. And many applications require completion of multiple independent tasks. Many are such applications, but many also require multiple or run multiple interdependent tasks. And for such applications, we use the term workflow, or the workflow is known term, not only by us. And these workflows are used to describe a complex job which involves a set of interdependent tasks. And the task is a unit of work that has several attributes. What are some conditions before running the tasks? What are the conditions after running the task? When the task can start, and so on. So we will see how we describe these tasks. And two types of tasks exist, let's say, also in our language. One is composite, which is a structure that describes a subset of tasks and their order of execution, maybe maybe run in multiple instances in parallel, in sequence, and a primitive or base task, which means that they cannot be decomposed into a smaller or simple tasks. And in our case, in serverless, primitive base task would be a function in the cloud or an action in IBM, while a composite function would be also we call them compound functions, which side, they consist of multiple or one of multiple primitive or also compound functions. I will cover this in more details later. Now, which type of applications we have or work applications? On one side, we have business. On the other side, scientific workflows. Let's give some details briefly. Scientific workflows usually run some extreme scale scientific research with a lot of simulations, and the whole application, all tasks of the workflow are executed. Usually, we would like to run as many as tasks as possible of the workflow, and in scientific computing, this is exactly the case where all possible tasks that are consisted in the workflow are executed. Then they process a lot of data, usually from sensors or whatever. They have usually thousands, million tasks that should be executed inside the workflow, and they consist usually from some parallel loops, parallel sections, sequential loops, and also parallel sections are known also as bag of tasks, which are independent, multiple independent, but also could be dependent with sequential loops, for example. These are examples of such scientific workflows. On the other hand, business workflows also are workflows, but they have somehow different requirements. They usually have some branches, if, switch, and so on. I don't know, if you buy a car, you can buy a car, you can take the car from the shop, you can I was abholen. You can take the car, but if you have paid already, so if you have paid, then you can take your car. So usually such are business workflows, how we call them business workflows. They also have thousands or maybe 15, maybe not so many functions, but could have multiple functions. But the issue is that they are usually lightweight. I don't know, store in a database, print this document, and so on. So different types of requirements they have, as I put here. Or I don't know, store data from a sensor. And here are two examples of two workflows. One, genome on the left side, which is a scientific workflow, and it calculates, I don't know, there is input data, and it doesn't matter. I mean, I will not bother. You can read. I will give you the link of this workflow implemented in three in step functions in IBM Composer and in our language. But the issue is that if you see this diagram, it's let me just draw something. So we have three parallel loops here. So 1, 2, and 3 loops, and parallel sections. The first one is this one. So start a parallel section here join, here again start a parallel section and join. While business workflow, if we see, this is okay, change alert we call, how to organize, what should be executed if a gate is changed on an airport. So read the flight, then select passengers from that flight, and we would like to inform all passengers that the gate is changed. And then we create a parallel loop for each passenger, one iteration. We would like to inform the passenger and at the same time, so parallel, calculate time to gate. So take the current position of the passenger and calculate time to gate, and then if then else. If there is enough time to go there, plenty of time, recommend go spend some money at the airport. Or if there is not enough time to go to shopping, recommend go directly to the gate. Different types of requirements are needed in both workflows, in both workflow types. Now, how can we describe the dependencies between individual tasks of the workflow? Using control flow and data flow. Control flow means when to start a function, when can we start a function, how many instances we can start of the function, shall we start the function, maybe we don't need to start, and so on. So control defines, shall we wait another task to finish and only then I can start the task, or maybe run multiple instances of this task. I don't know, read from the object storage of IBM, and if there are 20 files, run 20 functions in parallel. Don't run one which will go over all 20, but run 20 and use or submit one file to each function so that we want to speed up. And this would be the main goal of homework 3 in this case. And also could be that we want to control with conditional branches, as I mentioned with the example with buying the car. And data flow, for example, if we have 20 files on the storage, shall we submit all 20 files on a single or pointers, I mean, references, not files. The function will read, will access from inside. Shall we submit 20 references to a single file or one only reference? So this is how can we distribute the data. Shall we replicate the data? We will see today if we have a single data item that we want to submit to multiple functions, then we need maybe to replicate this data and then submit as data item to each function of a loop, let's say. And at the end, gather the data if we run multiple functions, and then each of them calculates something. Maybe some reduction function is needed that will combine all results into a single file, or maybe sum up the all outputs and so on. And of course, it defines which data item comes in the which data item yeah, we should define in the tasks or in functions data inputs and data outputs. But what would be the source of data input and where to store data output also defines the data flow. I don't know, if function A sends data, or let's say if a function B needs data from the output of function A. And this is the data flow between functions. Based on the control flow and data flow, workflows can be defined as control driven or data driven. And recently I reviewed, and I think it's published already, that paper, where some colleagues from Barcelona data center, they proposed, I forgot their system. I can find. They proposed to define how to define workflows in both cases. So both control-driven and data-driven workflows. The goal is that, I mean, the issue is that control-driven workflows, this means that a task has to finish and then another task starts. So one task can be started when we have the control reached to that task, and the control can be wait some data input from another task, and then which just finished. While in data-driven workflows, each task will start when the data is here. We don't need to wait some other function to finish. What is the difference? Let's say one task can run 1 hour and then generate now one data, after 3 seconds another data item, after 5 seconds another data item, and so on. And data driven workflow would be each time this function, I don't know, stores some data on storage, invoke another function to do something with that data item. While control flow means, okay, finish the task, generate all data into a single file, for example, or in a single bucket, or in a single entity, and in a single resource, let's say, and then only run the next function. Of course, one would say, yeah, data flow are faster. Another would say control flow is better, or I don't know. You have more controls here. We can run the things faster. I'm not arguing what is better. I'm just saying different approaches. Of course, control-driven workflows, one of the control will be wait the data to come. Of course, this will be, but the issue is that the data will come only when the previous task or one of previous tasks is finished. This is the main difference in both approaches. Okay, now how can we describe dependencies between tasks? We can do explicitly, we can compose the workflow explicitly. If we distinguish the dependencies between tasks and we see tasks as nodes, so that in this case we somehow abstract the dependencies in one language or in a separate part, while what will be executed in each task, in this case we don't care, we just execute that. While implicitly, the other way would be implicitly, where we create a high level language which can the output of this high level language can be explicit composition of the workflow. Let's say IBM uses this approach where in IBM Composer we use JavaScript to build the dependencies, and then from that they create explicit file or explicit description of the dependencies. Another way would be develop the workflow directly in the language, let's say in Python. Instead of building dependencies, build Python application, how this works, and how the I mean dependencies, or like a program. You develop the application like a program, and then parts of the codes you can offload as functions, as tasks, and so on. This approach, as I mentioned, is used, for example, by pivren, where they read the code that should be executed and then function executes the code. But again, what is better, what is worse? If we use explicit development, we can run tasks in different languages, for example. We are not limited to a single language. If we develop the whole application in Python, then we would, like in pivren, then we are limited only to Python. So again, there are trade-offs between two approaches. Again, I would avoid arguing against or pro and contra. And if we use the first approach, let's say we could use UML or there are, I don't know, 20, let's say, workflow management systems, not for serverless in general, which are famous in the world. Some use GUI to build the workflow, some use Python, some use Node.js, and I don't know, there are different approaches, but mainly there are two from the highest level. Now, let's go to serverless now. So what we focus on in this course is serverless. So how to define workflows from serverless functions or from FAS or FCs, how we call it. So in general, an application can have tasks, and tasks are interdependent, and tasks can be executed in general on a VM, in a container, or as serverless functions. I don't know, maybe some other options, let's say binaries, but on a physical machine. But as a matter, mainly these are three types of resources that exist in the edge cloud continuum. Okay, maybe GPUs, but it's mainly parallel, I would say. Okay, and if we have a serverless workflow, we call them function choreography. So if we use FC, this means that. Now, how can we build a new workflow, new function choreography? There are two steps that are needed. One is to develop functions or develop tasks, and we can develop tasks from scratch by creating functions, let's say developing ones, and then fascify. Sorry, this is first. We can develop functions with the falsification of the existing code, like we had in the previous homework, or we can use approach with which we had, which I presented with JS to FAS. This is the output of our bachelor thesis, where we develop the function only once locally, and then the tool will create for multiple providers. But in our case, this is the same because mainly we use IBM. Or we can do manually. Yes. And then the second step would be, okay, I have individual tasks that should be executed. Let's connect now which task will start when and after which task and so on. So develop dependencies. And usually I divide also the stakeholders here in two different, let's say I define two different stakeholders. Developing the specific tasks should be the work of IT, of the developers, of you, let's say, of students or IT engineers and so on. Developers of the dependencies or of the business logic should be done by someone who is from the business, from the management, someone who understands the process. Let's say the example with the gate change alert. So who will develop the gate change alert? I mean, who will develop dependencies in YAML file in our language? Of course, some IT guy maybe will write YAML file, but who will define the dependencies? Okay, first I need this, then I need that, then do this. This should be developed by the or determined by the business guy, or we call them FC developer, while then specific tasks go to the database, read there, I don't know, run some AI algorithm to predict something. This should be done by some IT, or we call function developers. And you can see the implementations. Here is the link. Okay, I would not go. I think I mentioned this last week, but nevertheless. So here you can find the, let's say, for GCA or for Genome implementations in Aave step functions. So how the same workflow is represented or developed or built in different languages. And even there you have the, how to say, the graphical representation of three workflows. So you can see the implementations in Aave step functions, in IBM, and in our language. But for our language, we will manage as soon as possible. I try to be faster to go to that one. Then to build, okay, these are three. Okay, I mentioned this. I will skip this. Then instead of building a new workflow, we could FCify, or we could extract the workflow from the existing application, from the existing monolith. And here would be built, we could use falsification to offload parts of the code of the monolith and then keep the structure of the monolith. And like it's written in our paper, we can use DAF to update also the existing code of the monolith so that parts of the methods or parts of the codes that we select will be offloaded to lambda function as lambda functions, and then code of inside the code of the existing method or of the existing part will be replaced with the call to that function. And then we still keep the FC as the monolith, but parts of the code will be offloaded. And also another tool is Node to Fast. if you want, you can try that. But we show in our paper that we cover more dependencies, which we saw last week. And the weakness in this approach is that they keep the monolith style, so that if, as I mentioned last week, why we would need to offload acceptable sometimes, if we would parallelize the monolith, and maybe in Node.js it's impossible, maybe it's possible, but we need to develop maybe more. Instead, let's say building from scratch what we will have in homework 3, we would achieve higher performance. If in if the problem allows this, of course. If not, maybe we keep just as it is as it is in the monolith. Now, portability. If we develop a workflow or an FC in IBM Composer, this means that we have the workflow in IBM Composer and functions on only one on one region of IBM. Similar, if we have on Amazon, we need to develop. I mean, if we need to move to Amazon, then which steps are needed? This is the challenge now. What we want to solve. So, since we had two steps to build the workflow, two logical steps. I mean, first build the tasks and then build dependencies. Both cases or both steps are needed again. Move the workflow and then move functions as well, because if we move the workflow from IBM on Amazon, first we cannot, because we need to redevelop it again. But then Amazon step functions cannot run IBM functions. So that we need to move also all functions from the workflow on Amazon. So these are two steps that are needed, and it's easy. So we need to develop. We cannot port the workflow to Amazon. We cannot, or we, yeah, manually we cannot port, let's say, with one click. Of course, if we use uh, our tool to JS to fast, then yes, we can build functions for multiple cloud providers. But in general, it's not an easy task to move a function from one to another provider. So these are two steps that are needed: port the workflow and port functions to the other FC system. And the challenge is, another challenge is the assumption in our JS to fast tool is that cloud functions do not use any other cloud services. If they use, makes sense to migrate them as well. So that if we run a function on Amazon, but the function uses data from IBM, then it's a questionable whether we would like to move also the data in S3, for example. Maybe we don't need, maybe we cannot move. This is implementation detail, which is depends on the problem that we want to solve. So non-portable solutions that providers offer today is this what is presented on the figure. So if, let's say, in our course up to now, we are IBM developers that, okay, we are here. Sorry, we are fast developer on IBM functions, and if we would like to build a complex application that controls multiple functions, then we need a developer for IBM. But then if we want to migrate to Amazon, then we need to learn another language. We need to, which is for AWS step functions, and then of course migrate functions to AWS Lambda, so that AWS step functions can run this. And if we decide and move to Google, again, do the same. Instead of that, our idea was, let's build one language that will define the workflow at the highest level of abstraction. So define tasks only, then connect dependencies between tasks, and then be able to run the whole workflow on IBM, on AWS Lambda, and on Google and on other on other providers. But then we said, okay, let's go a step further with our engine. Instead of running the first issue from run workflows on full workflow on a specific cloud provider, let's split per function even, so that if we have such workflow, let's say here is, we call it XAFCL, execute AFCL. We are still waiting reviews for this paper. And in that case, okay, green go to IBM, yellow go to Amazon and or orange, and blue go to Google. So from the same application, I'm not saying that this is the fastest way, but we offer to the runtime system a way how to describe our execution plan. So per function, and as far as I know, we are the first that offer this, at least first official. Okay, it's still not published yet. Yes, we are waiting to publish it. But I believe that we are still first in at this, doing this. Of course, I will repeat again, we are not saying that we can we will benefit always, because maybe when we build a scheduler, maybe the scheduler will always decide about the same execution plan, but we will see at least for the next homework, so for homework 4, where we will cover limitations of the existing these FC and FAS systems. This for sure would be very helpful for this portability per function, let's say, would be helpful to overcome those limitations. Okay, now let's focus on the language, because this will be useful for at least homework 3, 4, and 5, and maybe for 6, and of course for the project as well. So our language is AFCL based language. Sorry, it's YAML based language. Our AFCL language is YAML based. It consists, as I mentioned, of base functions and compound functions. So in base function means that you have to specify inside the function which function you execute. While compound function means combine multiple functions inside, could be compound, so nesting and recursively, uh, uh, and you can have compound functions inside, and of course you should have at least one base function inside compound function. It doesn't make sense to have nesting, I don't know, parallel loop inside parallel section and then branches, and you don't have any function inside base function. This, of course, you need to have something to execute. Then you need to define both control and data flow constructs. We go today with this. And connections among functions. And additionally, optionally, but something is mandatory, I will for this, to specify properties and constraints. Constraints we will cover for, I think, homework 5, but properties you would need at least one property resource, should be specified even for the homework 3. This is the base. Okay, maybe it looks scary, but we will go one by one, part by part. This is the YAML representation of a base function. So what is a base function? This is a function that should run some task, some real action in IBM, for example. So we need to have a name, but this should be unique inside the workflow, the FC. Then we need the type, but type for you would not be so much important. The type, why do we need type? Just to give you an idea, why do we need this? Let's say I want to run one algorithm. I don't know, matrix multiplication with a naive approach, implement it in Python. And then my developer leaves and I take Java developer. And I would like to have a new implementation in Java and then deploy on IBM or deploy on Amazon North Virginia. So this means that we would have the same type. The type shows the semantics, what the function should do, but not how it is implemented, where it is deployed. Or for example, run a function with 128 megabytes, then deploy it with 256. Oops, we have already two implementations, but from the same type. So the goal is that for each function type, we would have, let's say, 50, 100 implementations to give an option to the scheduler to decide which implementation should be optimal, should be used to achieve optimal execution. Could be fastest, could be the cheapest, whatever is required. So in your case, you could use type whatever you like. So I leave it to you. Just if you, let's say, if you use the same implementation, for example, in homework 4, you would need to deploy the same function on multiple regions. Then you would use the same type of function, but later in properties you would use different resource or different implementation for a specific region. So that for this part I will cover in lecture 4. Then a function needs inputs and outputs. So we define data ins, which is an array, so that the function can have one or multiple data inputs and one or multiple I mean, okay, not one you can even, you don't even need, but let's say in general, we would like to have one or, for example, maybe we want to run a function, just send an email, and then input is email text and output we don't need. So in some cases, we don't need output or we don't need an input. Maybe we have predefined something in the function. So data inputs and data outputs, so data ins and data outs, we could have multiple. For each of them, we need to specify a name. And here, important is that this value should be the same as for each data item. This name should appear in the as key in the JSON input to the function. Then we need to specify type. Is it a string or you have supported all primitives are supported. And additionally, type can be a collection if we would like to distribute data among multiple iterations in a loop, or afterwards to collect those outputs to collect in a single data item, which will be type collection. Okay, and then for each of data inputs and outputs, of course, also we can put properties, let's say size of the data and so on. And in constraints, we can specify later in fault tolerance, we will see we can specify earlier startup, later startup time, or shall we manage this, how many times we should repeat execution. If this I would leave for that case. Yes. What is the source? Well, yeah, I didn't come to there. The source, yeah, thanks. So the source is could be a constant, could be sorry, in the value could be a constant. The source could be we have a function 1 and function 2, and source of data in to function 2 is the data out of function 1. So this is the data flow how we can describe. Or could be some URL, read data from URL, some from S3 or somewhere. So could be some well-known link, or internally we could have data flow between functions. And then value can be, if it is a constant, then in the value we can have a value. Yeah, and did I miss something? Yeah, okay. These are, yes, in the properties, in properties, yes, this is important. In properties, we need here a resource. We need to specify a resource for which function we will execute. Uh, our why do we call AFCL? The goal is that first we build the workflow without specifying which implementation to execute, but we want this to be decided during runtime by the scheduler. But because in our course we will not have enough time to do everything, you will write manually your implementations that you have here in the resource field in properties. There it's given in the homework. I mean, it's published already. Homework. You can see the example with the resource field, and also I will open a workflow example, and then I go through that. Okay, now what give you up to now, I think here is written. I took, I mean, mainly the text is from more or less from the paper. I guess name, type, yeah, I think I covered all. Yes, the resource is mentioned, and the constraints, these are examples in the constraints what we can put. But for now, ignore constraints, and in properties, we would need the resource field. And data, yeah, I mentioned this about, so data ins has to be the same as the input as the tags in the input JSON, and output of the function that will return again as JSON. In data outs, we should have the same key in the YAML file. This is the restriction. So if output of function one gives, I don't know, some output price, then in the YAML file, in data outs, we have to have name price. Afterwards, if function 2 uses the same data item, function 2 doesn't need to use again the tag price. It can use name, I don't know, tags, but then source can be the output of function 1 and slash price. So that the key value pair in the input to function 2 can be arbitrary name. We don't to have the same name if the data item goes from a function to a function. But input to the function to be the same as the name in datains, and output of the function, so the generated JSON from the function, should contain the same tag as in data outs. And as I mentioned, data ins can be output from a function, from another function, can be input also from a parent. So data ins can be specified to be output of another predecessor function, can be input from the parent, and also can be some constant value. So up to now, what I mentioned, what I told you about the base function, similar attributes can exist for compound functions, but plus additional types or additional fields that should be configured for each of them. For example, we can define a sequence of two functions, or we can define if then else, switch, conditional branches. We can define sequential loops with for and while, and parallel sections, which means divide different codes, and parallel for, which means divide data for the same code. At the moment, we support those that are marked with asterisk I mean, the enactment engine supports these. For a sequence, it's just for the language to have that. You don't need to specify a sequence of two functions. You can just simply place them one after the other in the YAML file. So these are examples of parallel and parallel for. For others, I would, because these are needed for the homework, let's not give you so many details today. So I focused on to prepare slides only for homework 3. So you would need, okay, parallel maybe no, you don't need, but parallel 4 you would need. This one you will need in lecture 4, so parallel you would need there. But for homework 3, you would need to create the parallel 4. And as you see here, again, we have a name, data ins, data outs, similar holds for as a base function. And then we have loop counter, which has a name, type, but these are important from 0, let's say, until 10 with step 2. And then we will run 5 iterations in parallel. Okay. And then what we will execute in loop body, we execute at least one function. As I mentioned, we have to have at least one function. This function can be compound function again, but inside at some point we need a base function, because we cannot just create control, but then we need to run something. Okay, yeah, this is I show you then, or you can also check examples with our language implementations, but I will open some, and in the homework it's given an example of a workflow so that you can test the engine. Okay, now element index. Yeah, now we are coming to data collections. So if we have a loop, a parallel loop especially, we would like to distribute the data among all these functions. So if we have an array of from 1 to 10, we would like to run 10 functions and then distribute the data, or collect the data from all these functions, as I mentioned. Therefore, a data type could be not only integer or string, but could be collection. And then inside the collection in constraints, we could specify which data elements we want to have from the collection. Or maybe if we need all fine. But with element index, we can specify this. And this is the grammar. I mean, it's given in the paper. Let's say this with comma separated, we can specify individual indexes as number 1 at the moment. So number 1 is from this one. And then 2, 4, 6 start from 2 until 6 and with step 2. And then with this grammar, we can we can select 1, 2, 4, and 6. But I'm not sure if you use this. At least for homework 3 you don't need, but just to mention. Then block, this you should need, this you will need. With block, we would like to distribute the data among iterations, and this overlap you don't need for the homework, but you need size. So if we specify block 1, and we have a data collection with 10 elements, and in the loop we have 10 iterations, then we should use block 1 in the data input to the parallel 4, so that the engine will will split the collection into one and then send one item to each function. I will give you example for when we read the homework. I will show you then how to use for the homework. But this is the goal that you split with the size. Let's say if you have a data collection with 10 elements, will you split? For example, if you run 5 iterations, then you would split by 2. If you run 2 iterations, then you should split the 10 elements into 2 arrays of 5. So into block 5, then you will use. And maybe we would like to replicate the data so that if we have, let's say, n number of passengers, if we would like to submit n to any function inside the loop, then we would use replicate. And you can use replicate asterisk to or a star to replicate for each iteration. So in your homework, you would need that as well. Yeah, I mean, okay, maybe your solution doesn't need, but I recommend to use that approach. And in this case, replicate 2 means from each data item, we create 2 replicas. And if we have a single data, let's say n, which is the size of the array, and we need to send this to each function, then we would need replicate, and the replicate will replicate with n or asterisk, which will create n copies of one element, and then distribute each element to individual iteration. Okay, now let me show you. I think, do you have some questions? But I propose to show you now the editor. I don't know if someone tried, and maybe to try to create, I don't know, create a parallel loop. Every one of you should create parallel loop, or let me show you first the editor, and then better to check the homework, and then I propose to try directly for the homework, or I also have an example of a workflow, so that I would ask you also to try to run the engine with the example workflow, with the example function, and the example input. So let me show you the editor. I would just, if you because you may use that for the homework instead of writing manually, or instead of using the API. I think with the GUI is better. Just to share the screen. So if we go here, let's say we can go to functions. Okay, I don't need that. Oh, sorry, not functions here. So you can see that you have workers, you have fraction monolith type, and reduction. So these are 3 functions that you should use in the homework. So let's say if we have a function, we add a function. Of course, we need to add this begin and end. And if you go to the function, okay, you can change the name of the function, but you don't need it. Here you can see that we can add input data and output data. So you can go and put a name, choose a type, and here in the properties, in the properties here you should write resource. And the resource is in the homework you have, I mean, wait, I will open to show you the resource. The resource is the link of your, so here you will write resource, and in value you should write EU, Great Britain, slash, I don't know how was cloud functions and so on. So here you should put your function that you need to invoke. Then atomic function. Yes, if you add, let's say you would need a parallel 4, and you should put function. Okay, not workers should be outside, but nevertheless, this is just to propose to give you a hint, just to see if you have questions or no. So in this case, most probably you would like to connect input from the workers to be source to the, let's say, source. You need to specify source for data input, and you need to create some data input, and you can specify that data input goes. Let me check if I can. Ah no, okay. No, I want it differently. This I wanted to show. So we don't allow, or you should not allow. I don't know if you have checked in the paper. You should not connect successor function into the inside of the part of the compound function, because if we would use if then else here, and then and we have another function this way, and then both outputs of test function and workers to go to parallel 4, maybe only workers will be executed. But if we take the input from hello world to if the input of hello world is directly sourced to test function maybe will not be executed, so therefore we forget this. So you should not. I mean, it's forbidden even here, but just to mention that. And what else? Wait, let me go now. Also here you can add the same. Yes, loop counter, and oops, and then from to step. So all parameters or attributes in the YAML file you can find here. Properties, here you don't need resource because it's parallel 4, but you would need from to, and yeah, we need to connect. So I would propose that we go with the homework now, or if you wait, I will stop sharing. Let me check properties I mentioned. Yeah, load store. Okay, you can load you can load. Yeah, let's check the this one. Hello world YAML. So this is the workflow that is given in the homework, and you can check. So when you click here, you see the input. The name is hello world, and it has a name and type string. Output is yes. Let me show you about data ins and outs with the workflow. Yeah, let me open hello world. So data ins. So the name is hello world. Here is the name is hello world of the workflow. Then data ins to the workflow is name, and source is name. So source is this, but name of the value of data ins is name, and this should be the tag in the input JSON. And what is given input JSON is here name. So this tag should be the same as here name, this one. Then the input to the function is again name, but let me check which is given to your this is input to the function. Yes, sorry, this way. So the name, this is name which is inside the function should access the name. Let me show you with the output is better.
Excuse me,
So
I think
the
we are
the
supposed to
data
see the
out,
screen.
no, this one. Data out from a function. So we need to run a function, a single function. Here is a single function, just to check. Oops. Oh, sorry. Why I shared? Maybe I clicked cancel. Sorry. So wait, I don't know why. It's, then let me. Yeah. Okay. Now I guess you see. Yeah. Sorry. I guess it's stop sharing somehow. I clicked. So this is the. Let me go then from the beginning. This is the workflow which is given for your homework just to test the engine. But I want to use the same example to show you how names or how data ins and data outs, what are the needed, what you should be careful for when you build the homework. So the function hello has an, a name, has a data input, which is a name, and this is of type string, and source is hello world slash name. If we go here, function, name is hello, type, you as we mentioned, you would not make sense for you ignore this, but data ins is name, and the source is hello world name. This name can differ from this name, but this name here, this in quotes, has to be the same as what we have inside the function, what we expect inside the function. So the JSON which is input to the function should have this name. JSON, which is the input to the workflow, has to have this name. And if I open here, this is the input for the workflow and it has a key name. So this name in the input to the JSON, in the JSON input to the workflow has to be the same with this name. Then this name in the function has to be the same as the input to the function, JSON input to the function. Because we specify that the source is hello world slash name, then the same JSON file, which is input to the workflow, will be submitted to the function. Therefore, this name should be the same as this name. Okay. Let me check. Yes, okay. Then let's go now, hello. The output data is message. Let's see why. If I open the given hello world, return message. So I return a JSON with a key message, and therefore output of the function should have name message. And output has name message. Otherwise, you will get a failure. You cannot read, then try. I mean, try, or don't try if you trust us. Okay. Then let me check once more if I open the workflow again. So this is message because the output of the function is a JSON. Let me check if I can do this way. Yeah. So if I go hello, hello has output message, and this message is data out. End of type string. Okay, sorry, not this one. This is the same, sorry. Where is the, wait, where is this one I was looking? Yeah, sorry. So this is the function. From the function we have message, and this message has to be the same in output of the work. So what we see here in the GUI is the same with this code. So this one is the same as this one, start, hello, end. And if I click on the white, I see workflow, hello world, which has output message. And that's the same what we have written here. But why message is because we will use the same output. So the output of hello, which is message, and that's function is hello. So the source for this data out is hello message. And hello message is function name hello and data out message. And this is name message because inside the JSON, the output of the function returns also message. And we want to return the same output of the function to the workflow. Okay, now I propose to, let me check if I show you everything. Yeah. So now I propose that you, or if you want, we can make a break. But I would propose that you read the homework, and then because this is a little bit longer in the text, because there are multiple inputs, not that because the homework is not difficult than previous one, but I think because it's new, let's go step by step. I propose these steps. First, you read the homework, then we check whether something is unclear with the text, and then the first step while we are here, I would recommend you test to run. It's one command. Just download the engine, download this example workflow, download the input to the workflow. I mean, it's one key, and put the or deploy the function in your account in IBM, and try to run this example. If it works, then I am sure that you will your workflow will run. I want to be sure that you are able to run the jar file, the engine. Just I didn't mention you. Wait, I forgot something. So if I go to the workflow, so here when you deploy your function, replace your function ID, how to say. So update this one. Okay. If you deploy the function in another region, okay, change this, of course, but copy the whole resource file. So yes, this I wanted to say. Here is this I forgot to mention. So in the function properties, we have name resource, and value is which function I would run. Course.json, because we want to get the JSON from the output. I think we mentioned this last time. So these are fields that you should fill in your homework. So you have three functions in the workflow for the homework. You need one resource for each function to specify which function you would run. Later in the homework 4, we would run multiple implementations of the same function type, but for this, we go step by step. Next the week after. Let me check. Yes, I propose that you copy the whole string from your function when you deploy. Like when we invoked with HTTP, you have your code and you put there. Yes, so I agree. You need you take depends. Yeah, if you use this function, use how to say use the URL from IBM. Copy the from anyway you need to update. Maybe you will use in London or I mean not in London. London is maybe you will use Frankfurt or I don't know. So yes. Wait, I will try now. Uh, wait, I think you don't need. No, okay. Fine. So shall I, let's say, have a break or I mean, just read the homework. I mean, at the end, I don't need a break, but just to give you, I don't know, 15 minutes, let's say, to read the homework. Would it be fine, or you want first to make a break and then read the homework? Let's say how much is now? Let's say 2:30. Yes, let's meet. I will. Okay, yeah, perfect. I didn't want to push you to use the break, but I would pause the recording and at quarter before 3, let's discuss about the homework. But I'm here. If you have some questions, please write on the chat. Then pause the recording. Okay, I think we can continue. So let me open this and to open the homework. I cannot see now this. Okay, then I use this. Just in the meantime, I would like to give you example how to use. I think I didn't show you this. So you can use in constraints. You need to specify distribution and then specify either replicate or block. So for where was that? Let's say the output of the first function of the workers is function monolith. Just to find the text. Yes, the input to the function workers is n and k, and you would need to the output of the workers is workers number of functions, then placements from is placements, and placement per function is the constant value, so that the workers uh, and or what was the needed, so placements from is different for each function, while placements per function is a constant. So for those that are constant and you want to submit to every function, you need to use uh, distribution and then use replicate. Use this one. While for those that are an array and you want to distribute the array, then you can use block 1 for distribution. So constraints inside the data, data, wait, let me think, data, it should be in data ins in parallel 4, you would like to distribute to different iteration. And if you use replicate, then that output will be replicated to each how it's called, iteration. So at the beginning, please try that you are able to run the engine, the jar, with the given input. I mean, the given workflow and the input for the workflow, and deploy the function. I mean, okay, it's one line. I mean, Statements from binary. Yes, I would say yes. But why do you times n and wait, let me check. N power n. Sorry. Okay, okay. Yeah, I thought n square. Yeah, okay. So the idea is to split the total space of search space into how many workers we have into so many chunks, and then we send to each function starting from, and then how many, then starting from the how many, starting from the next how many. So that the start point will differ for each function, but the how many will be fixed. And that's, as far as I remember, that's the output of the workers. I mean, this is a proposal. If you have another way, you can try. But I think you don't need to spend time to go into such details. So maybe for the project, maybe you would need, but for homework, it's fine this way. Input data for your works. Just, I think I mentioned, just click on the white and then you see the workflow. On the panel in the middle, on the white, wherever you click on the white, it will show you. To be fair, a fair comparison for task 2 in homework, what you could do is, if you want, of course, it's not mandatory, because anyway you have the implementation for your execution, how to execute the function from homework 2. What you could do is adapt the workflow input or build from scratch the workflow with the function from homework 2 and run through the engine or with the engine. You can do this also for task 2. So similar like the example workflow, just you need to adapt inputs of the workflow and inputs to the function, and of course outputs of the function, and then you can run the function also with the engine, with the enactment engine jar as a suggestion. Did you all try to run the engine? Can you run? Do you have a problem with Java version, or at least this to be sure that you are able to run the example which is given? Then of course you should build the workflow. But on Monday, if you cannot solve, or if you have some uh, I don't know if you get some error when you run your workflow for the homework to test the yeah, I get the new pointer. No, you don't need to specify a credential file. I mean, you can use like we did, like without authentication. You can make the functions and then invoke them without authentication. You don't need. Aha, yes. Or if you don't put JSON in front, sorry, not JSON, JS, also it can give the same problem, as far as I tried. Do you understand the requirements of task 2? Why we increase A? What does this mean? Do you expect their speed up or not? Or we see it next week, okay? But we can discuss also for that if you want. Yes. So because the homework two, let's say, okay, we adapted a little bit function fraction, but in general it's the same. We adapted just the input. The goal is that instead of running the whole search space in a single function, we would run multiple functions so that we reduce the work per function. P is this is that n p is some number integer. That 3 is how was in mathematics? 3 is I learned this way that n could be 3, 6, 9, 12, 15, and then p is 1, 2, 3, 4, 5. But you don't ignore p. Ignore it's 3 is 3. N is divisible with 3. I guess this is the English word. Yeah, I wrote you use this one. Yeah, it's no problem. Let workers, let me check. Of course. Wait, I need to check this. The distributor should be power, not multiplication. Yeah, somehow like that. Yes, yes. Therefore, n should be can be n divided by 3 should be integer. And then you raise to power 1, 2, 3. So the just to give, and I try to write mathematically, but the goal is that you split the work to 3 functions, to 9 functions, 27 functions, and then the total number of search space you divide with the number of functions. We need to merge block together to calculate data. How do you mean to merge block together to calculate data? Let me check how it's given. No, if you create a collection, the data out of the parallel 4 should be a collection, and by default it collects all outputs of all functions that are inside. This is for Zoe. So you need just to specify the collection for the output of the how to say of the parallel 4, and then the input to data ins to to reduction will be again collection, and source should be the output of the parallel 4. Yeah. So that's the idea of the language, to not to do that collection. It's done automatically by the engine. In JS 9.2. Yeah, okay. I mean, this. Yeah, but this I see in from Tobias in JS. You can develop workers and the other one reduction in any language that you want. This is free. So feel free. Which language is for you the easiest one? You use that language. It's fine. It doesn't matter. Even it would be interesting when we show results next week. It would be even interesting to see different maybe performance. But of course, when we compare with function one, maybe it will be unfair. But expected is that we will get anyway speed up. Someone maybe will get slow down when you increase k, but let's discuss this next week. Why? And that would be the entrance to lecture 4, of course. Yeah. Okay. Why is n divided by 3? Well, therefore, as I mentioned, we let's say the goal of the homework is to split the overall space. So when we have n9, so to test with n9, and then n is 9, so therefore we divide by 3, and the how to say, the goal how to split is to split to 3 functions, to 9 functions, to 27 functions or workers, then 81 workers. Therefore, because we had for homework 2 n equal 9 as test, so I kept the same n equal 9, and therefore to split the work by power of 3. Is it fine? Yes. And because okay, not in homework 3, but in homework 4, you should run the same task on 3 different regions. So again, that's number 3 again. So you will see, I mean, after 2 weeks. So expectable to get again higher speed up. So when we increase k, we run more functions. When we reduce k up to k1, then we run only 3 functions. And if k is 0, then you run one function, but that's homework 2. So therefore, we start with k equal 1, equal 2, k equal 3. So don't increase k 20. I mean, it would be too much. So try 1, 2, 3, maybe 4, and then probably you will get a failure due to the I mean, no, you will not get a failure. No, you should get at least you will see. I mean, once you get some crazy results, stop. Okay, and then write in your answer and explanation why. But don't start 3,000 functions. I mean, go how much would be. I don't know, go to K4, let's say. 243 functions. Or you can try, I don't know, N12 maybe, and then use K1 and 2. I mean, if you want, it's that's another option. I would propose to that you build first the workflow. You create functions with inputs and outputs just as needed, and then run the workflow with empty functions. And once this works, then use the then develop the other two functions, or first develop functions and then works. I mean, however, I mean the functions are simple, not complex. Okay, we have 15 minutes more. Can I ask you on Monday, is the time slot fine? Because last week no one came before that. If you need some other slot, please write me. I can define another slot for let's say before the because the deadline is Wednesday. Could be, I don't know, even on Saturday. For me it's the same. I if you or just send me an email and leave me one day and then I can try to help you, because maybe Monday is in the afternoon and then you have only Tuesday more, or okay, Monday afternoon and Tuesday for to solve the homework. microphones is too sensitive, but it's a good microphone. Oops. We have no homework for 1 week, and then the second week we have less than a week. Well, I would not say that you don't have a homework for the next week, but each homework is for 1 week, these which are mandatory. And for the week after the homework presentation, I give you homework, but not mandatory, to read some papers to prepare for the next lecture. So I would say that you have each week homework. I define that way. You have each week homework, but 1 week is mandatory, another week is optional, how to say. But this doesn't mean that okay, you don't need to read anything. I mean, I tried to, as I mentioned last week, or the week before, I tried to extract some related work regarding the topic that we cover. Mainly, I cover on lectures the part of the topic, let's say the work. In this case, it's ours, but let's say at the end will be some other work. The work, what we work at the moment, we try to use our work in homeworks. I mean, in in the topics, because we do this work anyway. And for other works, I give you, okay, read these 5 approaches, 3 approaches, and then compare with our approach. And this is the idea that I expect that someone, if you read Note to Fast, or I don't know, some other, did someone check how, let's say, step functions work? This is my idea, that during the last week you should read other approaches, not only our AFCL. Therefore, and why the Jonathan, sorry, so I will come to your question again. So do you think that 1 week is less, or it's effectively it's fine 1 week, but you would like to have 2 weeks for each development homework? How would you prefer? So we pass the parallel connection and give it property of replicate. Pass the parallel connection. So yes, you add yeah, okay, parallel as input. You mean as input? Yes. Okay. Sorry, I didn't see as input data. Yes, the you need to give three inputs to function to fraction, which means you need to pass the data, the input, the outputs of the outputs from workers. You need to pass to the parallel 4 as inputs, and then when you pass you specify would you like to distribute this to inner functions or you would like to replicate, because parallel, what is parallel? Parallel is a loop of multiple times it runs the same function which is inside. This means it makes sense to give different data for each iteration. Just it's the same as for, but it's executed in parallel, which means that the input data or there is no dependencies between each iteration. For example, if you have some while loop, while not equal 1 or 0, let's say, to find a divisor of some number, then you loop the same while, but you divide by two by two by two. Let's say to convert an integer into binary, you divide by two always and take module of two, module two, modulo two. So in that case, there is a dependency. That has to be a sequential loop. Mhm. I think I will figure it out. Yes, you can specify. Yes, you can specify a value which is output of the workers. Yes. So loop counter is type number, and it can start from 0 until the output uh, of the workers. Yes, Marcus, you can use the input from the whole workflow. Yes, you don't need to. I let me check. Was it specified that the workers? I think they don't return. As far as I yes, please check in the homework. Workers should not return in. Yeah, let me check. But as far as I remember, I wrote that the no wait. Yeah, on page. So worker function returns workers, placements from, and placements per function. So semantically, the goal of function workers. Let me give you, motivation why workers are needed. Workers decides. Let's say somehow like some scheduler. Workers decides based on the number n of queens. It will determine how many functions to execute. Okay. So how to divide based on number n of queens? We have total number of it's one-to-one mapping to total number of placements of queens, and then how to split all those placements with this k, and k is input to workers, and the workers outputs how many workers you will run. based on n and k, you determine w, and w is n divided by 3 power k. So workers receives n and k and replies with w. That's the main goal. Documentation for the AFCL toolkit fields. Yes, didn't I send you that? So if you go to this page, um, yes, you can use output of workers. Yes, as number for counter two. From is zero, two is how many workers you would need. So the loop should go from zero until number of workers, or minus one. I don't know how. No, I think you don't need minus one. So you can specify. So just to check one more. Yes, so if you go to our web page, I mean current web page, maybe we will extend it and update it, but this yeah, it's not still published. Yes, there is no link to this. It's still under development. So there you have the scheme for the language, and uh, all constructs from the from the language. But as I put with comments when I cover the lecture, which are supported by the language. So you can use if, uh, I mean not in this homework, but for the project you would need if, switch, parallel, and parallel for. These four constructs, and the base function, of course. So for the homeworks, uh, I'm. Let me think, Jonathan, about this. But I think it's. Then we should switch the. No, I'm. If we do that, I'm afraid that you will work, or maybe, I mean, not you directly. Sorry, that students would wait 2 weeks and then one day before the deadline, everyone will work. Therefore, I think we should not go that way. And because the course is VU, we need to have both, let's say, part of pro seminar and part of lectures. And somehow, therefore, I divide it into this way: 1 week for practical homework and 1 week for not theory, let's say, but it's still somehow a development part, but just to see different solutions for, or different approaches. And also, I don't want to give you the homework before covering, what is the topic about. And for example, now if I gave you this homework last week, you couldn't solve it because you don't know the language, and then you will start sending me 20 mails. Is this way, that way? And I think now it's better when we cover this way. But okay, I mean. So just once more to repeat that the goal is that each week we have a homework. I'm not saying that 1 week we don't have, 1 week we have. Okay, because that shouldn't be that way viewed. Shall we finish? I mean, I don't want to spend. I have time, no problem. Just because we had only 15 minutes break, so we should finish. Let's say we should be already finished. I mean, so if you prefer, we can close the session. If not, I can wait still for some questions. Okay, just I don't want to say let's close, neither close nor I mean I just propose. I don't want someone of you to say Sashko kept us until 4:30. And go. So feel free to send me an email and anytime with I don't know screenshot or with an error if you get an error or if you don't know how to do some part, send me. I will give you hints. Feel free to send me. So just to go briefly, input to the workflow you have two inputs, N and K. Those two inputs you need to transfer to the function workers. So source for inputs to workers should be inputs to the workflow. Then workers resource you specify. Then workers you need to specify how many? Three outputs. Those three outputs, some of them should be collection if you have an array, or data number or string. Then those three outputs should be input to the parallel for. Inside the parallel for those three inputs, you need to specify either replicate or block. If the input is a single number that should be transferred to each function inside to each iteration, you create replicate. Otherwise, if you already have an array, the homework is done in such a way to be easier so that each iteration gets only one element to be easier. In general, shouldn't be the case. After that, those three inputs should go to the function as three inputs to the fraction. And how was fraction monolith given? Doesn't matter. So fraction function of n queens. Then you have that function. It outputs the output, and the output of the parallel should be a collection because it collects data from outputs from all function implement for all from all iterations, and then you just output those three as output of the workflow. Is it better this way? Okay, I think it's enough. So if you have any question, please just send me some email. And or on Monday also we can discuss or if you have problems. Okay, then I stop recording. And